Hello student, welcome and very good morning to you. Today I will be discussing a DPP on Coulomb's law and force between 2 point charges. This is the DPP 3 of electrostatic. This DPP will be extremely helpful to those students who are preparing for NEET, main, advanced and WB joint. Okay, I hope you will understand this video. Write a comment on this. This comment will be extremely helpful for me to make my video more and more better for you. Question number 1. Two small conducting sphere of equal radius have charge 10 microcoulomb and minus 20 microcoulomb respectively, placed at a distance r from each other, experience a force F1. So look at this, F1 equal to, this is the K into 10 into 20 by R square. If they are brought in contact and separated to the same distance, then the force experience F2. When they are brought in contact, then charge on each sphere, this is the minus 20 plus 10 by 2. So this is the minus 5. So look at this. Here repulsive force F2 equal to, this is the K into 5 divided by R square. Okay, no problem. So look at this, F1 is to F2. Look at this is the negative sign of minus 2. So look at this is the minus 8 is to 1. So look at this, option 2 is correct. Okay. Now question number 2. Two charges each equal to 2 microcoulomb are 0.5 meter apart. Both them exist inside vacuum. Then the force between them. Look at this, the force between them. This is the 9 into 10 to the power 9 into product of two charge 2 into 10 to the power minus 6. 2 into 10 to the power minus 6 divided by distance. This is the 0.5 whole square. Okay. So look at this. This is the 4, 36. This is the 36 into, this is the 10 to the power minus 3 into 0.5 whole square. So this is the 4. So look at this, 144, that is 0.144 is the magnitude of force between the two charges. Okay. Option 3 correct. Now question number 3. 2 point charges placed at certain distance r and exert a force F between them. So look at this, F equals to, this is the q square by 4 pi epsilon naught r square. Okay. Then the distance r dash at which these charges will exert the same force in a medium of dielectric constant K is given by. So look at this, same force F, this equals to q square by 4 pi epsilon naught K, this is the r dash square. So look at this, comparing this equation and this equation, we can get root K into r dash equal to r. So look at this, r equals to, r dash equals to r by root over K. Look at this, option 3 correct. Now question number 4. There are two charges, 1 microcoulomb and 5 microcoulomb. The ratio of force acting between them will be, look at this, the Coulomb's force of attraction is mutual force of attraction equal, mutual force of attraction and repulsion. So both the body exert equal forces on one of other. So look at this, ratio of forces is 1 is to 1. Okay. Now question number 5. The total charge Q is broken into two parts, Q1 and Q2, and they are placed at distance r from each other. The maximum repulsive force between them will occur when, look at this, when two charges are equal, that is Q1 equal to Q2 equal to half of the total charge, then force of attraction becomes maximum. So look at this, option 4 is correct. Now question number 6. 2 coulomb and 6 coulomb, two charges are repelling each other with a force of 12 Newton. Each charge is given a minus 2 coulomb charge. Look at this, when minus 2 coulomb charge is given to 2 coulomb, the net charge on it becomes 0. And this charge becomes, this is the 4 coulomb. So look at this, net force becomes 0 because the first charge becomes 0. Now question number 7. Two charges Q1 and Q2 are placed in vacuum at a distance d and the force acting between them is F. If medium of dielectric constant is 4 is introduced between them, then force now will be, look at this here, F dash equals to, this is the F by K. Look at this here, K is 4. So net force becomes, look at this is the F by 4. Okay. Look at this, question number 8. Look at this, question number 8. Force of attraction between 2 point charge is Q and minus Q, separated by a distance d, is Fe. When charges are placed in two identical spheres of radius r equal to 0.3 d, whose centers d meter apart. Look at this. So this is the d meter apart. As distance of separation are not large, so induction effect takes place. So net distance between the two charges decreases. Therefore, force of attraction increases. So look at this, that now final force of attraction greater than the initial force of attraction. Question number 9. Two similar spheres having charge q and minus q are kept at a certain distance. F is the force act between the two. If the middle of the two spheres, another similar sphere of charge plus q is kept, then it experiences a force of magnitude and direction is. Look at this. This is the sphere, this is the sphere. Okay. Now here charge q, here charge minus q. Now when a charge placed at this point, q charge, so initial this charge repel this charge along this direction by the force 4 times greater than the initial force, because look at this distance is the half of their initial distance of separation of first two charges. So this is the 4m, and here minus q charge also attract along this direction with the force 4m. So net force on the charge at the middle is, this is the 8f towards the negative charges. Okay. Now look at this, question number 10. The force between two charges 0.06 meter apart is 5 Newton. Each charge is moved towards each other by 0.1 meter. If the now the force between them will be, when each charge moves towards each other, this is the 0.1 meter, so net effective distance decreases to 0.02 meter. So net distance 0.06, this equals to 0.04. So look at this, the force of attraction increases 5 into, this is the 0.06 by 0.04 whole square. So look at this is the 3 by 2 whole square. So this is the 5 into 9 divided by 4. So look at this is the 11.25 Newton. Look at this, option 2 is correct. Okay. Now question number 11. Two charges placed in air repel each other by a force of 10 to the power minus 4 Newton. When oil is introduced between the charges, the force becomes this, the dielectric constant. You know, F dash equal to, this is the F by K. That is, force in a medium is equal to force in air divided by K. So look at this, K equal to force in air 10 to the power minus 4 divided by force in the oil 10 to the power minus 5. So look at this is the 10 by 2.5. So this is the 4. Look at this, option 4 correct. Okay. Now question number 12. The charges on two spheres 7 microcoulomb and minus 5 microcoulomb respectively, they experience a force F. So look at this, F become, this is the K into this is the 7 into 5 divided by this is the r square. Okay, now each of them is given an additional charge minus 2 microcoulomb. So look at this 7 microcoulomb minus 2 microcoulomb. So look at this is the 5 microcoulomb, and minus 5 coulomb and minus 5 microcoulomb minus 2 microcoulomb. So look at this is the minus 7 microcoulomb. So look at this net force between 7 and 5 is same as the net force between the 5 and 7. So look at this net force is F. Now question number 13. The ratio of electrostatic and gravitational force acting between the electron and proton separated by distance of 5 into 10 to the power minus 11 meter will be. Look at this. The electrostatic force by gravitational force Fg. This equals to, this is the 9 into 10 to the power 9 into charge of electron. Look, charge of electron 1.6 into 10 to the power minus 19. Charge of proton 1.6 into 10 to the power minus 19 whole divided by r square. Now gravitational force, look at this. This is the 6.67 into 10 to the power minus 11. Mass of electron 9.1 into 10 to the power minus 31. And mass of proton 1.67 into 10 to the power minus, this is the 27. Okay, whole divided by r square. Now r square and r square cancel out. Okay, so look at this. Look at this. Here 10 to the power minus 19 minus 19, that is 10 to the power minus 38 minus 9. So look at this. In look at this. The numerator becomes 9 into 2.56 into 10 to the power. This is the minus 29. And look at this here 10 to the power 11 and 10 to the power minus 31. So 10 to the power minus 42. Minus 42, and this is the minus 27. So look at this. This is the 6.67 into 9.1 into 1.67 into 10 to the power minus 69. Look at this 29 and 69. So look at this. This is the 10 to the power 40. This is the 9 into 2.56 divided by, this is the 6.67 into, this is the 9.1 into 1.67 into 10 to the power 40. Okay, look at this and this cancel out. This and this is the 1.6. Okay, so look at this is the 16 into 10 to the power 39 whole divided by 6.67. So look at this is the 2.36 into 10 to the power 39 is the ratio between electrostatic force and gravitational force between proton and electron. Now question number 4. Three equal charges are placed on the three corners of a square. If the force between Q1 and Q2 is F12 and that between Q1 and Q3 is F13, the ratio of magnitude F12 and F13. Okay, look at this is a square. Okay, look at this is the Q1, this is the Q2, and this is the Q3. So distance of separation between Q1 and Q3 is root 2 times the distance of separation Q1 and Q2. So look at this force is the 2 times greater than the force of attraction between Q1 and Q3, because this distance is 1 by root 2 times less than the distance of this. So look at this, option 2 is correct. Now question number 5. 2-point charges 3 microcoulomb and 8 microcoulomb repel each other with a force of 40 Newton. If a charge of minus 5 microcoulomb is added each of them, when 5 microcoulomb charge added each of them, the charge of it, the resultant charge on this is the 2 microcoulomb minus, and this charge is the 3 microcoulomb. Okay, look at this. Initial force is 40 Newton. Final force is F. So initial force, this is the K into 3 into 8 divided by r square. And final force K into, look at this, charge is the 2 and this is the 3 divided by r square. Okay, no problem. Look at this. This cancel out, this cancel out, this cancel out. So this is the 4. Therefore, 4F equals to, this is the 40. So F equal to, this is the 10 Newton. So look at this 10. So this is the minus 10 Newton because it is the attractive force, because this is the minus 2 microcoulomb and this is the plus 3 microcoulomb. Okay. Now look at this question number 16. Two copper balls, each weighing 10 gram, are kept in air 10 centimeter apart. If one electron from every 10 to the power 6 atoms is transferred from one ball to other, the coulomb force between them will be. So first of all, we have to calculate the charge in each copper ball. Okay. Now first of all, this is the mass of the copper ball. So we can calculate the number of mole here. So here look at this number of mole. This is the 10 by, this is the 63.5. If number of mole is multiplied by the Avogadro number, we can get the number of atom present in it. So look at this. This is the number of atom. If this number is divided by 10 to the power 6, then we can get number of electron transfer. So this is the number of electron transferred from one copper ball to other. So charge transferred, it should be multiplied by the electronic charge. Okay, so 1.6 into 10 to the power minus 19. So one copper ball, this amount of positive charge, and other copper ball becomes this amount of negative charge. Now, for simplicity, you can calculate this and this. This is the almost 10. This and this cancel out. Okay. So look at this. This is the 10 to the power 23 and 10 to the power 19. So 10 to the power 4. 10 to the power 4 divided by 10 to the power 6. So this is the 10 to the power minus 2. So charge almost becomes 1.6 into 10 to the power minus 2 coulomb. So another copper ball has charge minus 1.6 into 10 to the power minus 2 coulomb. Now force of attraction F equals to, this is the 9 into 10 to the power 9. This is the 1.6 into 1.6 into 10 to the power minus 4 whole divided by square of the distance of separation. Look at this distance of separation 10 centimeter. That is 0.1 whole square. No problem. So look at this. This is the, look at this. This is the 9 and minus 4. So this is the 5. 5 and this is the 10 to the power minus 2, 7. So 9 into 2.56 into 10 to the power 7. Therefore, look at this. This is the almost 0.9 into 2.56 into 10 to the power 8. Look at this option, sir. 2 into, look at this. This is the 2 into 10 to the power 8 Newton is the force of attraction between the two charges. Okay, understood. Next. Now look at this question number 70. Two identical balls each have mass 10 gram. What charge should the ball given so that their interaction equalizes their universal gravitation acting between them? Radii of each ball may be ignored in comparison to the distance of separation. So look at this net gravitational force. This is the 6.67 into 10 to the power minus 11 into mass of each 1 kg, 0.01 kg into 0.01 kg divided by r square. This equal to, this is the 9 into 10 to the power 9 into q square by r square. Look at this, r square cancel out. So look at this here, q square equal to, this is the 6.67 into 10 to the power, this is the minus 15, okay, divide by 9 into 10 to the power 9. So look at this is the minus 15 and this is the 9. So look at this is the 6.67 by 9 into 10 to the power minus 24. So q equal to, q equal to 10 to the power minus 12 into root under of, this is the 6.67 by 9. Now 6.67, this is equal to 2.5 by 3. So look at this is the almost 0.8. So look at this, 8.87 into 10 to the power minus 11 is the charge on each body. Now look at this question number 18. The diagram shows the arrangement of their small uniformly charged spheres A, B, C. Look at this. This is the A, B, C. The arrows indicate the direction of electrostatic forces acting between the spheres. Look at this. This A and C are the attractive force. Look at this. Forces towards each other. A and B also attractive force. Okay. And look at this, B and C are the repulsive force. So B and C obviously like charges. Okay. At least two of the spheres are positively charged. As two spheres are positive charge, so B and C are obviously positive charge and A negative charge, because A and C are attractive force, so plus minus attract. B and A are also attractive force, so B and A are opposite charges and BC like charges. Therefore, the body of A will be of negative charges. Okay. 19. Look at this. A charge Q1 exerts some force on second charge Q2. Third charge Q3 is brought near it. The force of Q1 exerted on Q2 is same, because third force cannot interfere the force of attraction between the two charges. Now question number 12. Two identical conducting sphere having unequal positive charge Q1 and Q2 separated by a distance r. If they are made to touch each other and then separated again the same distance, the electrostatic force between the two charges, in this case neglect the inductive charges, look at this, is more than the before, because look at this, as q1 and q2 unequal, suppose look at this is the 3 and this is the 7, so this is the 21. When then brought in contact, they have equal charge, so 5 and 5. Now force of attraction proportional to 25, so force of attraction more than the before. Okay, many thanks for watching this video. This video will be extremely helpful for your preparation in NEET, main and advanced. Okay, thank you.